Hello and thanks for watching Go Teachers Maths. I'm continuing to go through the Edexcel Higher Tier paper from 2019. This is paper 2 and it's a calculator paper. And we're on question 16, which is a question about straight line graphs. So we're given this straight line, which has got the coordinates, which is got the equation 3y equals 4x plus 7. And we're also told that there's a point A with these coordinates 3 minus 5. So what we've got to do is find the equation of a straight line that's perpendicular, which means that it's at 90 degrees to the first line. So basically, if it's at 90 degrees to this one, then we could say, imagine line L is something like this. Then we're looking for another line, which is at right angles to it. So it's going to pass through it like this. And that would mean it's perpendicular if that's 90 degrees. So the first thing in this is we need to find the gradient of this line L, which is here. So we're going to find the gradient as a step 1. And to do that, we're going to use the standard equation of a straight line, which is y equals mx plus c. And in this equation, m stands for the gradient and c is the y-intercept, and that means where it crosses the y-axis. So basically, m is the slope. So usually we find the slope by drawing a triangle underneath, and c is if we had a set of axes, c would be the point where it crosses the axes, something like that. Okay, so what we're going to do is we're going to take this equation that we've got for the line L, 3y equals 4x plus 7. I'm going to try and write it in this way. So in the form y is mx plus c. So we can see our first problem is there's no number in front of the y in the standard equation, but we have got a number there, which is a 3. So what we're going to try and do is get rid of that. And we can do that because this is 3 times the y. So if we divide both sides of this equation by 3, then we can get rid of the 3 on this side and we'll basically take it over to the other side, but as a divide. So we end up with y equals, and then dividing every part of this right-hand side of the equation by 3, we get 4 thirds of x plus 7 over 3. So that's now in this form, and we can see then for line L, then the gradient m is equal to 4 thirds. So we've got that. Now we then need to use a second bit of information, and that is if we have two lines that are perpendicular, then I'm going to call the line that's perpendicular MP, P for perpendicular, and that's equal to minus 1 over the gradient of the original line, the line that it is in perpendicular to. So in other words, it's the gradient of the perpendicular line is minus 1 over this gradient, 4 thirds. Okay, now that might look like a bit of a strange fraction because we're dividing by a fraction, got a fraction in the denominator there. But all that really means is we're going to flip this second fraction upside down. It's in the denominator, and it's going to become just 3/4, minus 3/4. So that's the gradient of the perpendicular line to L, to line L. Now we're after the equation. Now what we do know is that it goes through the point 3, minus 5. So that means x is the x coordinate of a point which it goes through is 3, and the y coordinate is minus 5. So again, we can go for the standard equation of a straight line. We can use y equals mx plus c. And what we what we need to do is we need to try and find the value of C. We've already found the value of M, which is this minus 3/4 for the perpendicular line. And we also know that from the coordinate that it goes through, we can put in a value of X and Y. So we can put in that Y is equal to -5, and we can put in that X is equal to 3 into this equation as well. And if we do that, that'll enable us to find the value of C. So I'm going to put them in. So I'm replacing the Y with -5, and that's equal to replacing the M by -3/4, and then I'm going to put in the value of X. So X is 3, and then we don't know what C is, but we are trying to find that value out. So that's equal to C. So if we tidy that up a bit, we've got -5 equals -9, so multiplying the 3's over 4 plus C. And if we take away, or rather, if we add the -9 over 4 to both sides, we get -5 plus 9 over 4 is equal to C. I'm just going to write the C on this side. So I've got C is equal to that. And I'm just running out of a little bit of space here, so I'll just do this over here. So I'm adding two fractions. So to do that, I need to make the denominators the same. And that's actually can be written as a 5/1, which is very useful when we're trying to add it to a fraction. So we can say, if we times top and bottom of the 5/1, we will get 20/4 if we multiply both parts of the fraction by 4 plus 9/4. Now we've got it like that, we can actually say that we can add them, and we can say, well, -20 plus 9 is actually -11 on the top, and it's all over 4. So we've got the value of C, and all we need to do now to get our equation is put in the value of C and the value of M, and keep Y and X as just Y and X, not actual values now. So we can say the equation of the perpendicular line is going to be Y is equal to, so the gradient that we found for the perpendicular line, which is -3/4 X, and then replacing the C by the value that we had, so -11/4. And that's it, we've done it. That's the equation of our perpendicular line to L. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel, Gary Teaches Maths. And for more help, view our website, which is bestmathstutors.co.uk. Thanks for watching.